Well, hello, everyone, and welcome to our webinar, KetoMonitor Delivers Big Picture Insights. We're co-hosted between UW-Madison and VAS. My name is Taliah Danzinger. I am an education specialist with VAS, and I will be following Dr. Heather White with some applications parts with KetoMonitor, but we'll let Dr. White kick us off with some of the science behind KetoMonitor and how it was developed.
Thank you so much for that invitation or introduction and invitation to join you today. And thank you all for coming and participating. I think that you'll find a nice complement between some of the scientific background I'll be presenting, but as was indicated, some nice application of what you'll see as well. So we're excited to present both sides of the story today. There we go. So as we all know, the transition to lactation period is a period that is potentially wrought with a lot of challenges. This is the period of which the cow is going from a gestating, non-lactating cow, and then she goes through that parturition event and the onset of lactation. And many of the challenges that she faces during this time are a reflection of the negative energy balance that she goes into as she's unable to physically eat enough energy to meet the needs of lactation. And that's shown schematically here at the bottom, energy consumed in yellow compared to energy requirement in blue on the left side of that figure. When she's a non-lactating cow or dry cow, it's easy for her to meet those energy needs and she remains in positive energy balance, this green line here. But as we have parturition and the onset of lactation, her energy requirements quickly exceed what she can consume, and she enters into negative energy balance. Although this is a period of great challenge, it can also be a period of opportunities, where as nutritionists and cow managers, we can improve metabolic health through strategic nutritional interventions, and we can understand individual variation between cows that are successful or not metabolically, and then go on to be efficient and productive cows. And so those are two things that we focus on in my lab. Some of the other opportunities that have presented themselves during this transition period are related to advancements in technology and in the data streams that are available to us on farm. One example of that is milk analysis. Historically, we might just think of milk components, fat, protein, lactose, but advancements in technology have allowed us to get much more comprehensive panels of information. And so another area of which I work in, and the one I'll be focusing on today, is developing these biologically based markers and predictions for cow health and physiology. These are specifically valuable in terms of metabolic health, because if we can predict or detect a metabolic health event before it occurs, then it puts us in a better position to intervene on farm and to have a successful intervention that improves animal health and productivity. One of those metabolic disorders that we focus on a lot is hyperketonemia, or subclinical and clinical ketosis. Hyperketonemia is defined as a blood BHB of greater than or equal to 1.2 millimolars of BHB. And there are cumulative effects as blood BHB increases. We know that there are more additive negative impacts. Some of those negative impacts would be an increased risk of displaced abomasum, decreased milk production, increased risk of culling in the first 30 days, and decreased reproductive performance. And we know these negative outcomes from a few studies that are in the literature, some of which have been done on university dairies, and some of which have been done on privately owned dairies. We also know from that past research that if we implement detection protocols for early detection and treatment, we can recover some of the potential negative impacts. However, we know that these detection protocols are expensive and laborious, and certainly less invasive ways to monitor health, energy balance, or feed efficiency. All of those things would be of use. And those are tools that we've been working with collaborators to develop. So specifically to monitoring subclinical ketosis or hyperketonemia, you'll hear me use those interchangeably, we were focused on trying to replace the intensive blood measurement, or even if we couldn't replace it completely, to add another tool to our tool set. So if we think about doing blood monitoring, the recommended detection protocols are typically to test every fresh cow in her first 2 weeks of lactation, or in catching each one twice, or maybe 2 times in the first full week of milk. But either one of those approaches, there's a frequency requirement. We require to get a blood draw or blood sample, which means you're locking up the fresh cows. So this is an intensive procedure, and it requires somebody to be in the fresh pen at least once a week, if not more. And so we set out to provide a database solution that would be more convenient. And our goal was to use management data collected and recorded by the farm, combined with milk analysis data, and use that to predict the blood BHB in a research study. The goal of this was to provide something that would provide a herd level insight, be less labor intensive, less invasive, and potentially allow for cost savings and efficiencies on farm. This work was completed actually shortly after I joined faculty at UW. This was one of the first projects I did in Wisconsin. And we published this paper that included equations that leveraged these dairy herd data. So things like days dry, milk production that we would be recording on farm, and with the milk test data. And these equations were developed for cows in the first full week after lactation, and then the second, focusing on that high risk period, the first 18 or 20 days after calving. We also had equations that we were able to develop for Holstein and Jersey cows. And so we were really excited when these were implemented. It's great to do research, but we all want that research to be implemented rather than just to live in the file cabinets of published literature. And so at that time, AgSource offered these equations in a tool known as the KetoMonitor. So now several years later, more years than I probably want to admit, but several years later, we've been able to look back at this wealth of data. So not only has the KetoMonitor provided feedback to the farms using it, but we've also been able to accrete that data or accumulate that data. And so we took an opportunity this past winter to say, okay, if we sit back and look at everything we've been able to gather, what can we learn from this tool? What can we glean from this? And so basically what we did was we took the KetoMonitor data from consenting farms that agreed to be involved in research. And that data set represented almost 260,000 lactation records that had fresh cow data within each lactation. And those lactation records came from about 330 Holstein dairy herds. We did limit this analysis just to Holstein because that's what we had the most data with. And so that's what we focused on. Our goal was twofold. First, we wanted to evaluate the relationship between predictive hyperketonemia or HYK status and potential risk factors. So these would be events that happened before the subclinical ketosis was predicted by the KetoMonitor. What types of things would precede that event that could be considered a risk factor? The second goal of this analysis was to evaluate the impact of predicted HYK status on cow health and cow and herd productivity. So what was the impact of that health event? Now you'll note I'm careful here to say predicted HYK status, and you'll see that I use P HYK or P non-HYK in the figures. We did not do blood analysis on these cows, so this is all data-based from the farm and from the KetoMonitor. And so I'll be careful to refer to that, but you'll see that we found a lot of things that are in alignment with blood-based predictions. So we did actually publish this both as an abstract at the dairy science meetings pretty recently. And then it was also published in Animals in open access journals. So you can find all of this if you're interested in diving in to the nitty-gritty results of this study. So to start, let's take a big picture look. This is a good representative set of farms across the upper Midwest What's our production look like, and how are we doing? So here we have the mean or the average of each of these variables, the minimum and the max. In the paper, we dive in and show all of the breakouts, but I just wanted to give you a taste or a feel of what the data set was like. So for each herd, so these are herd level variables, for each herd, the average number of cows tested, about 460, but those herd sizes ranged from 33 to just over 7,500 cows that were tested each month. Postpartum cows tested, so of those cows being tested, how many of them were in the first 21 days? About 220 on average, although you see the range reflects the range size of the farms as well. Overall, we're right at the predicted hyperketonemia percent that we think is consistent with across the country, right about 16%. Now, I will note this is prevalence. So remember, this is a single time point. It's the same as if we were to walk out to your fresh pen or the fresh pen of a farm you work with and take a snapshot set of blood samples. It's how many cows are positive on that day. Keep in mind, incidence, the total number of cows affected on a herd, is this prevalence times 2 or 2.5. Okay, so this is really consistent with what we know to be the averages. On average, rolling herd milk production's about 26,000 pounds of milk, and fat 3.8, protein 3.1, and we can see that there's some variation there. But overall, we're doing really well on production. So what we did for this analysis for the herd level was we divided up the herds into quartiles. So the bottom quartile, the 2 middle quartiles, and then the top quartile. And we used that in order to analyze what was happening at a herd level. All right, so based on these production numbers, the first thing we always talk about is that having hyperketonemia or having subclinical ketosis will have a negative impact on milk production. So let's start there. At the cow level, we did see just that. Cows that are predicted to be subclinically ketotic or hyperketonemic in the black bars had a lower milk yield, this would be peak milk yield or first test milk yield, than cows that were predicted to not have subclinical ketosis. But we found something really interesting and a little bit surprising when we looked at the herd level. We've always talked about decreased milk production, and I've often heard people question if subclinical ketosis is just something that comes with the territory, if you will, from having a high producing herd. And I've argued against that, and I think this data shows that quite well. As we look at the rolling herd average milk quartiles from left to right, so the lowest milk quartile to the highest, and you can see on the left here what those milk productions of the quartile are for the blue bars. So as that milk production on a rolling herd average increases, the predicted hyperketonemia prevalence decreased linearly. And this is really interesting and maybe a little surprising. It's certainly in contrast to the individual cow data I'm showing you on the left. And what this tells us is that just because you have a high producing herd or you're working with a high producing herd, it doesn't mean that you have a certain amount of subclinical ketosis you just have to accept. We can certainly have lower hyperketonemia despite high milk production. But we do still see that cows that get subclinical ketosis will have a decrease in milk production. And I'm going to come back to that later on in the presentation because we were able to dig into that a little deeper. The other thing I'll show on a herd level is the relationship of milk yield, predicted ketosis, and fat and protein within the milk. So if we focus first on fat in the black line, as the milk, as the rolling herd average for that milk fat increased, hyperketonemia predicted prevalence tended to increase as well. And this goes back to the long-stated relationship that a higher milk fat is sometimes associated with ketosis in fresh cows, although we have certainly found better indicators of that in recent years. What was really interesting was this sharp negative relationship between protein and hyperketonemia predicted prevalence. And this is something we're digging into a little more. In the literature, there's not much information and research studies about milk protein in subclinically ketotic cows or not. So this is something that's really piqued our interest. Going back to the fat, if we look at percent fat here in cows that were predicted to be HYK, looking at individual cow data, this will all be in blue, compared to those not predicted to be HYK in black, we see that classic increase in milk fat when a cow does have subclinical ketosis or is predicted to have subclinical ketosis. With recent advances in technology, we can now characterize that fat within the milk analysis. And so what I have here is preformed fatty acids. So these would be fatty acids in the milk that are coming from mobilized fat, primarily in the postpartum period, although they can also come from the rumen from diet. And we see that that's the fraction of milk fat that's increased. This makes really logical sense biologically because the cow with subclinical ketosis is often mobilizing more body fat during that time. And that fat then is available to the mammary gland. So not all things about subclinical ketosis are bad. There's probably some underlying nutrient partitioning reasons of why she does this. We won't get into those today, but I think this is really insightful because we are learning more about how to look at fatty acid profiles to interpret them more at the farm level. The other thing we notice is although the difference is not nearly as striking, there's a decrease in de novo fatty acids in cows that were predicted to be HYK or hyperketonemic. And these de novo fatty acids are the ones that are made in the mammary gland. And so we see a decreased contribution of those to the milk fat. So some exciting insights here and some nods to how we might increasingly use the fatty acid groups or components in understanding what's going on at the farm level. The other thing we looked at was somatic cell count. So this is something else you may be familiar seeing on your report. And there have been some relationships noted both in our original paper developing the models and by other researchers that suggest a higher previous lactation somatic cell count can increase risk for ketosis. And in fact, in our data set, we found that cows predicted to have subclinical ketosis had a greater previous lactation somatic cells count. So because it happened prior to the event, that would be a potential risk factor or a warning sign. When we looked at the current lactation, so at the bottom here, this would be the current lactation that the subclinical ketosis event happened in. And we also see an increase in somatic cell count across parities. So there was an interaction here, but each of the parities had an increased somatic cell count compared to cows not predicted to have hyperketonemia. Differential cell count is something that's of more and more interest, and this is the proportion of the cell count that's polymorphonuclear leukocytes and lymphocytes. Basically, this is the part of the somatic cell fraction that can give us insight into immune status. So it's really interesting because it's something we can now determine in milk samples and provide back to farms. That gives us more of an insight than just somatic cell alone. And interestingly, we saw numeric increases in first through fourth parity, but significant increases in the second, third, and fourth parity in differential somatic cell count in cows predicted to have subclinical ketosis. This is interesting, not just related to mastitis as we might think about SCC, although there may be a relationship between mastitis and hyperketonemia risk factors. But this is also interesting because of recent work looking at the potential role of immune status and inflammation in metabolic disorders postpartum. So there might be something else here that's a little more telling, and we're looking forward to digging into that more as we move forward. So all of these things taken together, we've started talking about mastitis now, somatic cell counts, metabolic disorders. We all know that the culmination of all of these can often lead to having to make those culling decisions, especially the involuntary culls, the ones you make in the first 60 days where you might not necessarily want to cull that cow, but you have enough reasons you have to. So we looked at culling within 60 days. This is as a percent. And across parities 1 through 4 and then 5 and greater here on the right. And cows that were predicted to be HYK had a greater percent of culling in each one of these parities compared to their non-HYK herd mates. And so these cows were being culled more. We looked at the reasons listed by the farm, and the most common reason, or the reason that had the biggest difference, was health, illness, depending on how that was reported. But there was also an influence of reproductive efficiency. So here on the bottom, we have days open, and you could see that the days open were significantly greater for cows predicted to have hyperketonemia. On the right, if we think about the illnesses, there was an increase in displaced abomasum. These are farm reported. So increase in displaced abomasum, an increase in milk fever in cows predicted to have hyperketonemia. So all three of these together certainly seem to have contributed to an overall increase in culling rate. Nothing here is super surprising compared to what we've seen in the past. There's quite a few papers that suggest that there are relationships between all of these disorders or health events. Whether it's causal or not often depends on which occurred first. And certainly this study wasn't designed to look at causality. But we have some strong evidence here that there's still relationships between milk fever, displaced abomasum, reproductive efficiency, and ultimately culling off of the farm. So these were all really exciting things to see confirmed within this large data set. Again, if we think back to the early research or some of the past research that's been done, even a large university type study may only include a couple hundred cows. These are really large, intensive studies. And so to be able to take a step back and use 250,000+ cows or lactations and be able to see the same patterns is really reassuring that we're looking for the right things. This also points out that these relationships should set flags off to us on the farm. You have a lot of displaced abomasums. It may be that there's an underlying ketosis issue or an underlying milk fever issue. Again, it depends on which is happening first, the causality of that, but certainly there's reasons to make sure we're looking more broadly if we have one of these challenges on farm. All right, so I promised you I'd come back to milk data, and I want to do it with a slightly different perspective now. If we think about these cows that are culled within the first 60 days, we were able to dig into the data set and see what those culling decisions did to impact the outcomes on production. So I know there's a lot of bars on this slide, and we'll focus on the top bar or the top graph first, which shows peak milk yield. Again, predicted HYK cows in blue, non-HYK cows in black. The difference here between this figure and the one I showed earlier are cows on the left side of the figure are the cows that were retained in the herd, whereas the cows on the right side are the cows that were culled. Okay, and then within each of those two fractions, we still have parities broken out 1, 2, 3, 4, and 5 and greater. All right, so if we look at the top here with peak milk yield, and we focused on the cows that stay in the herd, all of a sudden it doesn't take much to notice that there's no difference in milk yield between cows that were predicted to have HYK or cows that were not. In contrast to that, if you look at the right, the cows that were culled, whether they were predicted to have HYK or not, did make a difference in what their peak milk yield was. Now, obviously, we don't have cows in here that were culled before milk production peaked. So if they were culled in the first week, We don't have a peak milk yield in this data set for that cow because she wasn't in the herd and wasn't recorded. But this is really interesting because we see the dichotomy here between the two treatments is very obvious within the cows that were culled, but not apparent on the left. We see a similar pattern, although not quite as striking, for mature equivalent milk. So if we look at what the calculated ME milk production was for the cows retained within the herd versus the cows that were culled, there's a striking difference here on the right. In the left, their ME milk was still significantly less, but we can look at this and the difference is not nearly as striking as within the cows that were culled. So what's that mean? Why am I so excited about this? Well, it could mean that the cows that we're culling are the cows that would have the biggest milk production difference. So when you're making those culling decisions of a cow that you're treating for subclinical ketosis, this could mean that we're appropriately taking into consideration if she's still making milk or if her milk production has already decreased substantially, and maybe that's influencing the culling decision. It could also mean that it is the most severe cases of hyperketonemia that are driving the difference in milk production. We weren't able to dig into either of those answers in this study with the data that we collected, but both are possibilities. Either way, the take-home message here is that as a whole, across 335 herds, we're making smart culling decisions that are removing the cows that would have the greatest negative impact on milk production. And the cows that we're choosing to keep, that are responding to treatment, or that we're being diligent with detection and treatment on, are able to stay in the herd and still make similar milk, both at peak and then only a slight reduction at mature equivalent calculation. All right, so to go through some of these and to tie it together, based on the associations from this study, it suggests that cows predicted to have hyperketonemia had decreased milk yield and milk protein content on an individual cow basis, that they had an increased milk fat content and yield, and an increased preformed fatty acid content. Again, that provides some new novel insight as we're able now to break apart the milk fat components or groups, preformed, de novo, or mixed. And as we're learning better how to use those on farm, I think that provides some valuable insight. Cows predicted to have hyperketonemia also had increased somatic cell count, which is consistent with prior reports. Although the novel aspect of this study is that we also found an increase in differential somatic cell proportion. And that's a new finding representing a novel, not only a novel tool, but a novel aspect of understanding subclinical ketosis. We found consistent increased risk of culling and comorbidities like displaced abomasum, milk fever, and decreased reproductive efficiency that are similar to more intense but smaller studies. Unique to this study and very interesting is that higher producing herds had lower predicted HYK prevalence. And this is really key as we strive to improve management and nutrition. Again, that question I often hear is, having subclinical ketosis just something I have to deal with in a high producing herd? I think this data refutes that and says that we can have high producing herds with low prevalences of subclinical ketosis. And I imagine that that would reflect both management and nutrition. And when we're doing things right, we can have the best of both worlds. And then the last note here is that greater rolling herd average milk protein was associated with lower predicted HYK prevalence. We understand the biology of fat mobilization. When she milks off her back, we have metabolic challenges, and then we see that fat occur in the milk. And so we see increased milk fat. But seeing this marked decrease or negative relationship to milk protein percent across those rolling herd average ranges was really interesting, because I think this reflects that postpartum, especially during subclinical ketosis, we may be influencing amino acid or protein nutrition. And this was a novel insight that warrants us digging into deeper as nutritionists and as researchers. So some take-home messages for your farm or for farms you work with. Predictions of HYK status can be leveraged to provide insight into the consequences in biology. On farm, these can identify risk factors on that specific dairy. And I think this goes to what we've talked about as being a benefit of KetoMonitor since we've started implementing it, is that while this is not an individual cow tool, we do report back the patterns of cows predicted positive. And the power of that is you can look for patterns like increased days dry, or increased somatic cell count. That might be a pattern and a risk factor on that specific farm. And that's really valuable when you're trying to troubleshoot and work towards lowering that prevalence. Herd level monitoring can identify expected associations, including the predicted hyperketonemic status, having greater risk of culling and comorbidities. Again, as I mentioned when we were looking at that data, there's often one problem that we talk about first, whether we think it's a subclinical ketosis problem or a displaced abomasum problem. But these associations support us looking at the whole cluster of things that could be challenges and opportunities in the postpartum period, because there are such strong relationships and associations between them. And on-farm, early detection of HYK could curtail negative outcomes. I think that's twofold. First, if we can detect individual cows early and treat them, our go-to treatment is still an oral drench of propylene glycol for 3 to 5 days, we can curtail the negative outcomes on that individual cow. So we can recover some of that potential lost milk. We can decrease the risk of comorbidities. But on the larger scale, on the herd level, I think that's where that culling data is really insightful as well. If we can't recover that cow, but we haven't ignored her, we've detected her, that may help us make those strategic or informed culling decisions when that's something we need to do anyway. So with that, I'd like to thank all of the students in the lab that contributed, specifically Tawny Chandler and Ryan Prawley, both involved in the first original work. And Ryan Prawley, now faculty at UW-Platteville, was my co-author on this analysis together with Gary Etzel in the vet school at UW, and funding sources of the research program, generally speaking, and VAS for inviting me to present today. So with that, I'm happy to take any questions, or if we want to jump to the next presentation and take questions at the end, that would be fine too.
Sure, thank you, Dr. White. Right now, we don't have any questions in the Q&A. So for those of you participating on the webinar, please feel free to put those questions in the Q&A. We will have some time at the end to go over those. Otherwise, I'll go ahead and share my screen and jump into the on-farm application piece of utilizing KetoMonitor. And I feel really fortunate. I was able to take part in some of the first on-farm applications of KetoMonitor when we were just exploring what impact this could have on the farm, bringing the data out and trialing it against what we knew was happening on the dairy, and seeing that change reflected in the data displayed on KetoMonitor. So it's really fun for me to come full circle now and see what the lactation records, 250,000 plus lactation records say about KetoMonitor. And really leveraging KetoMonitor on the farm comes down to two things. We want to track the things that we know about and the things that we don't. And what that means is that we can utilize the data from KetoMonitor to measure what's happening in those cows when we implement a protocol change, when we know that we've changed feeds. But we can also analyze that data and look back to say, what is happening, what has changed, and start digging for the answers that can help us be more profitable. When I explore KetoMonitor on farm, there's kind of 5 different ways that I start to look at this data. So the first would be seasonality and the fact that ketosis is really dynamic in numerous ways. But then digging deeper into timing, lactation number, protocol changes, and then my favorite would be hidden opportunity. So how can we utilize KetoMonitor to uncover opportunity that we didn't even know about because of our current protocols for testing for ketosis? To start off with seasonality, we've got a really interesting data set here from Dr. White, but it really demonstrates how dynamic ketosis is. And when I say it's dynamic, I mean this in two ways. One is that it's seasonal, and we'll look at that data next. But the other is that it's really farm dependent. And just because we have a higher low level of ketosis today doesn't mean that that will stay consistent tomorrow, next week, or in the following months. So what this chart on the right-hand side here is showing us is weekly blood BHBA testing on a single herd and the percent of cows that were detected over a blood BHBA of 1.2. What we can notice here is that we went through periods of time where ketosis was quite high, between 50 and 60%, and those times too where we weren't detecting a single cow, down at 0% here. When we look at the way that ketosis changes just on this single farm, it makes me call into question how we implement protocols and how we measure those protocols and change them over time. I think that as we're looking at ketosis on farms, the best thing that we can do is be nimble and be willing to evaluate protocols that we are utilizing on the farm and be willing to change those when the data indicates that we should investigate further. Now, in order to make those changes and be nimble, again, we have to have the data and we have to be reviewing it. On the seasonal aspect, this is data coming in from all of the cows that we've been milk testing. So this is data from all of the cows going through the VAS line over a number of years, 2017, 18, and 19. And what we see in this data is that there is a seasonal effect, but it's not consistent year to year. So if we examine 2017 data, the darkest blue lines, you can see towards the end of 2017 going into December, we saw an increase in prevalence across the board, all cows coming through our lines. This actually continued into 2018, the green lines, but then decreased over time going into summer. When we look at 2019 data, the lightest blue or the third bar in each of these individual months, that prevalence didn't follow the same seasonality as 2018. If we set our protocols only based on what we saw here in 2018 data, we wouldn't be shifting with the seasonal changes we saw across the board. So seasonality is a factor in ketosis, but it's not consistent year to year. We see differences in here, and a lot of this can go back to us getting this data from the Midwest and perhaps some of the things that we see that impact our Midwestern farms as a group. So I keep talking about trying to maximize that efficiency if we're just using a single protocol, if we're using multiple protocols. And I think this set of KetoMonitor data really illustrates that on a single farm. So this is 2 years of data on one farm. And this farm does have a seasonal effect to ketosis that they've recognized and we've discussed in team meetings. You can see that that prevalence in those older cows increases starting in August and September here. And that trend carries over year to year. On this particular farm, we've identified that we have an issue with carrying over enough feed inventory. So when we go into new crop corn silage, we're feeding that not totally fermented new corn silage. We know that we head into this ketosis prevalence issue. But that's not the only thing we see in this data set. We ended up with an independent increase in ketosis prevalence in those first lactation cows. That's not similar year to year. This was an entirely new issue on this dairy. So if we examine how we choose to blood test cows, how often we're checking these cows, who we're checking, if we used a single protocol that we developed in January of 2020, or a single protocol that we developed in October of 2020, are we going to be hitting the right cows? And are we going to be hitting them at the right time? So in these charts, we're looking at that overall prevalence for all cows 5 to 20 days in milk. We can break that down further and look at the impact of timing on ketosis. Are we seeing it in our early fresh cows, or are we seeing it across the board? And knowing the timing of ketosis might determine how we mitigate the risk and who we're focusing our attention on. So these blocks in KetoMonitor look at when ketosis is occurring. Is it in the early fresh period, which is going to be the pink lines? Or is it overall 5 to 20? When we say early fresh, we're looking at 5 to 11. What we notice here, these are two different farms. The timing of ketosis isn't always consistent. So in the top farm here, we see changes as to when ketosis is affecting our cows. There's months where our prevalence is highest in the early fresh cows, and those months where we don't see it at all in early fresh cows. So in this case, we might be looking at different sources for that ketosis, and our approach to lowering ketosis, which cows we're going to test and treat, that all may change depending on what this data shows for us. Block C paints a really different picture on the bottom here. So here we've got a herd that for the previous 11 months or so, we have not detected any early cow prevalence. Part of this goes back to data integrity. So I'm going to talk about that at the end of this presentation. In order for this data to be good and for us to be able to apply it to what we're doing on the farm with our management, we have to make sure we have good data integrity, which includes making sure that we're testing those cows in the sick pen if they're early fresh. We're testing all of our fresh cows, so we're getting a good data set here. This herd is testing those early fresh cows, but we're not seeing that ketosis prevalence there. So we might take very different approaches between these two herds. An example of how we might use this for troubleshooting goes back to a farmer scenario I ran into a couple years ago. This farmer was blood testing all of their cows 3 to 10 days in milk in the fresh pen twice. So this is a really common protocol that I run into on farm. Everybody's probably going to be pretty familiar with it. If those cows were negative at 10 days, they got moved to a bigger pen. However, this farm was detecting a lot of DAs at 21 to 25 days. When we looked at those KetoMonitor results, we determined those cows were getting ketosis after that pen move. So we were doing all of our blood detection in that 3 to 10 days in milk range, and we were catching ketotic cows through KetoMonitor at 12 plus days in milk. So there's two ways that we need to look at this. Number one, our short-term solution. Who are the cows we should really be checking and intervening on? Going back to what Dr. White had mentioned, we can intervene on these cows and create a different outcome for them if we catch this ketosis. But the overarching picture here is, why are our cows getting ketosis after this move? We need to look at what we can do to reduce the prevalence of ketosis in those cows post-move. And the fortunate piece of this is that with this data set, we can continue to monitor the impacts of any changes that we make. We should also be concerned about lactation number. And KetoMonitor can shed light on management impacts. Dr. White had mentioned this portion of it, looking at days dry and age at first calving. So here's a snippet looking at the individual cows that were predicted to have ketosis on a particular herd. And we can start to pick out some of those individual management pieces here in dry period length or age at first calving. So this is something that we can examine our data and then start digging back into our herd management software, other data sources that we have, to look at what these cows have in common and perhaps how we can change how we manage these cows to mitigate that risk. My favorite lactation example is this next one here, though, our first lactation animals. We don't typically expect to see ketosis in these animals, so this can really easily fly under the radar. How often are we checking our first lactation animals for ketosis? And have we designed the right protocols for the right populations? This example here shows a farm that is experiencing very high levels of ketosis in their first lactation animals. We've got some months here where a prevalence level, now again, we're looking at prevalence. Incidence is typically 2 to 2.5 times prevalence, which really multiplies the effect of what we're seeing in these cows. Some months here where prevalence in first lactation is 40 to 50%. So we really need to examine what's happening on the farm to cause this really unusual pattern of ketosis. What scares me about situations like this, if we're not monitoring this data, is if we are not blood testing these cows and we're not looking at KetoMonitor data, we could be having a whole lactation group that's flying under the radar and causing other effects on our farm when it comes to performance and culling and reproduction that are masked by the lack of testing. Going back to talking about how we're going to measure the things that we know about and the things that we don't, here's an example of measuring change with KetoMonitor. So the impact of a change can be missed if we don't look for it. I know the stories behind these two herds. These are two different herds. On the left-hand side, we've got a herd that made an intentional change. So here, back in February of 15, they chose to change a number of things in their fresh cow program to reduce ketosis. So in this case, they made a ration change and they reduced overcrowding in their pre-fresh. This is a fun example because it was one of the first really big examples of seeing how we could track the impact of those changes with KetoMonitor. And what we saw here is that it worked. We saw a huge reduction in prevalence of ketosis. We were able to maintain that for a number of months. Now, the other fun part about this chart is we saw it sneak up later. And so this would give us those warning bells that it's time to investigate something new. On the right-hand side is a herd that I was on recently that had an unintentional change that caused an increase in ketosis prevalence. We made a big ration change to try to push for more milk production based on what the co-op had allowed them for milk production. And we thought that things were going pretty well in the cows. But when we dug into that KetoMonitor prevalence, we actually saw that that ration change came with an unintended consequence. We had really increased ketosis prevalence in those cows in the exact same time period. Based on what Dr. White had just talked to us about, we know that we don't need ketosis to be a high producing herd. So we can dig into this a little bit further to figure out if we can further influence this herd for better milk production. So we've talked about a lot of different snippets here, different things from different herds. And I want to walk you through the hidden opportunity that we found in a single herd. To me, this is a fun example because this is a phenomenal herd. If we look at a snip here from their herd summary, this is nearly a 100-pound herd, 30,000-pound rolling herd average, and probably one of the best somatic cells I've seen in my life. 42,000 somatic cell rolling herd average. So, you know, we're looking at this herd. If I'm showing you this herd, there must be something wrong, right? So I'm not going to show it to you for no reason. So let's dig into repro and dry period length. There's really not a whole lot to see here either. We've got 99% of our cows dry with an appropriate dry period length and a preg rate of 39%. This is a phenomenal herd, very well managed herd. So let's flip gears and look at transition. When we look at TCI here, we find we're starting to shed some light on what might be happening. If you're familiar with TCI or transition cow index, we're making a comparison of that cow from her previous lactation to her current. And what we want is a high value of TCI and a very low variation within the herd, that all of our cows are telling us a consistent transition story. On this herd, what we're seeing here is that our trend is just barely above zero when we look at that 50th percentile, and we have a lot of variation in these cows. You know, we're seeing a couple thousand pounds of TCI variation between our top and bottom cows. So this tells us that transition might be an opportunity. We also see some kind of high turnover rates for this dairy. So our average turnover rate less than 60 days in milk is 8%. This particular herd is at 7%. So they're doing a little bit better than average, but we just looked at all the rest of their data. This is not an average herd. So I would expect their turnover to reflect their above average management across the board. And when we get into KetoMonitor, we get some insight here into what might be causing some of this. This herd actually doesn't do any blood detection protocols, and they found that they were experiencing a high number of DAs in later lactation, over 14 days in milk. So when we look at that ketosis prevalence over time, they've been a lot of variation in here, and we've had some months with very high prevalence, over 60% here back in May of 2019. When we examine these cows, the timing of that ketosis really matches what they've been seeing for those displaced abomasums. Those ketosis cows being over 12 days in milk. So even on this farm, when we see that they are probably hitting the 99th percentile in somatic cell, hitting that in rolling herd average milk production, pregnancy rate, this herd still has opportunity. So we can tackle that opportunity in KetoMonitor, use that report to measure the impact of changes, and hopefully get this herd to that next bar or the next achievement that they want to have. So overall, let's look at some of the best practices that we can implement to ensure data integrity. First of all, we want to test the right cows. When I say that, I mean, don't skip the sick pen. Those are the most important cows that we can test because we can glean so much information from that data and get some insight into what is making that individual cow sick so that we can make changes across the entire herd. The other piece to this is ensuring a regular testing interval. Sorry, there's a typo there. We want to make sure that we are testing all of our cows frequently. Every 4 weeks is ideal. When we get out to those 6 and 8 week intervals, we're going to be missing some data here. And so we're not going to get as accurate of a picture as to what is actually happening. We want to apply the data with care. KetoMonitor is best as a prevalence indicator, not an individual cow finder. We want to use this to measure the impact of changes that we make on the farm. But we can look at those individual cows and go back, blood test those cows, make interventions on those cows if needed, because we do have a reason to look at those cows. But again, KetoMonitor is meant to be a whole herd picture. And finally, we want to utilize this data consistently. We can utilize it when we're making that intentional change, but just because our prevalence has dropped down to what we consider an acceptable rate doesn't mean that we can stop looking at this data. Because the other really important part about KetoMonitor is measuring that unintentional change and looking at it to be a warning bell for us when something might be starting to go wrong in the herd, so that we can have that early intervention that helps us increase profitability. With that, I will leave our contact information up here, so you can feel free to email Dr. White or myself with any questions. I'm going to go ahead and check the Q&A and get some of your questions answered here. So for Dr. White, one of the first questions we have here is, since the hyperketonemic cow is short of glucose, would you not expect a higher percentage of metabolizable protein to be converted to glucose in the liver, thus resulting in lower milk protein levels?
That's a really good question. I don't know who asked that, but you know, we were thinking about that. There's clearly some nutrient partitioning going on here, and maybe there is the use of some glucogenic amino acids. So some amino acids can be used as a glucose precursor. I think that we have to be careful when we think about that, because some amino acids can be glucogenic, but would also have a much higher priority within the body. So if we think about limiting amino acids, those probably aren't going to be used as a glucose precursor, but it's very possible that there are other amino acids, alanine is a great example, that could be used. The other thing it probably indicates to us is a use of mobilized muscle, so amino acids from mobilized muscle tissue as a precursor during that time. So we talk about mobilized body fat, we talk about negative energy balance, but we have to remember that the cow is actually in negative energy balance, negative amino acid balance, negative glucose balance, negative nutrient balance, right? She's short on a lot of those postpartum. And so she may be mobilizing amino acids to meet that deficit. And if so, there may still not be enough left yet to partition to milk protein. So I'm thinking exactly along the lines of your question, and we even proposed that in the paper that was probably a likely thing.
Another question for you. Did you examine the association of metritis and that increased incidence of hyperketonemia?
That's a good question. We did try to look for that. Unfortunately, because we were using farm reported data only, we did not have consistent reports of metritis across enough of the farms to look at that. So what we did with the health incidence data was, of the farms that reported health events, we analyzed the relationships. But if we were below a certain threshold, we didn't dig into that, because we didn't know if farms were not reporting that health instance, or if it was just very low prevalence. So we had some thresholds we used within the data set, and so I don't have good data on metritis for you. We did look at retained placentas, and there was an association between retained placentas and hyperketonemia prediction.
Question here on the overall prevalence, the two categories are 5 to 20 and 5 to 11. Shouldn't the 5 to 20 group always be larger than the 5 to 11?
Yeah, so I think you're talking about on the actual KetoMonitor output, and it should, the absolute prevalence should, but those bars are shown as a percent. So sometimes we see a discordant relationship there because of the percentage. So it depends on how many cows are within each of those brackets as well. And there's a few instances where we can calculate it out, and they don't always have to have the relationship as you describe.
The next question here is, I agree that KetoMonitor is a good tool for identifying weaknesses at the herd level. What do you recommend at the animal level to identify at-risk animals? Is KetoMonitor really an alternative to individual BHB measurements?
Yeah, that's a really good question. I would consider it a part of our tool set or part of our toolbox. So I like to see them used in conjunction. I'll give you an example to answer the second part first, and then I'll come back to the first part of your question. If we look at some of the patterns over time that were shared, I think that there's justification to blood test individual cows at some points when prevalence is high, but at other points when prevalence is really low. If prevalence is lower than 10%, it's probably not economically justified to test every individual cow, especially if you're short on labor, if we're out trying to harvest corn silage right then and you need to be able to reduce your to-do list a little bit. So I think there are times that we can strategically say, okay, the pros and cons of this, we can skip individual cow blood testing right now. If we're doing that, having the KetoMonitor also flags us to make sure we start retesting when the prevalence increases. And so in that way, I look at it as leveraging multiple tools and combining them into a comprehensive tool set or a comprehensive management style. The ways to test individual cows, the best way remains to be a blood BHB meter. And 2 examples were given both by Taliah and myself of either testing cows twice in the first full week, so in that kind of 3 or 4 to 10 day range, or testing each cow once in 2 consecutive weeks. Either way, your goal is to grab her twice in that fresh period. Some herds have most of their subclinical ketosis in the first week, in which that first strategy works better, where you're really doing it intensively in the first week. Most farms I see do really well with the second option, where you pick a day of the week. Maybe it's Monday, somebody's out in the fresh pen, they test every cow that's in the 3 to 18 day range. And then the next week they test her again. And the reason that works well is because the natural progression or duration of subclinical ketosis is about 5 days. She's either going to get worse and show you obvious signs if you haven't tested her yet, or she might self-recover. And so if we're testing with that frequency, we can catch most of those cases and treat them early. And so I think that one works really well. It also works well once a week because our recommendation for treating with propylene glycol is 3 to 5 days of oral drench. So if we think about testing once a week, you go out Monday, she's positive, you start 3 to 5 days, depending on your preference and how severe she is. We need to give the rumen a few days to rest from the oral propylene glycol, and then you can retest her on Monday. So we're not testing her while she's getting her treatment. We give her a few days and then we test her again and make sure that we have successfully treated her. So I think that those are 2 really good tools or approaches on an individual cow basis.
Excellent, thank you. The next question here, I can take a shot at. How can a herd enroll in KetoMonitor, and do they need to be recording BHBA testing? One of the really cool things about KetoMonitor is that you don't need to be recording BHBA testing. And in fact, we are collecting data on all of the cows tested by VAS, formerly known as AgSource. So any cow going through our direct member milk lines is already getting this data calculated on them. So if you do choose to enroll or you want to see a sample report, you're actually going to get back data for as long as your milk has been running through those lines. So we're collecting that data regardless. It's whether or not you choose to view that report. If you're interested in enrolling in KetoMonitor, you can talk to your milk testing technician, or you can get a hold of me with the contact information above. As long as we know your herd code and some other information there, we can get that taken care of for you as well. Another comment here, very nice topic and paper. A similar paper with similar outcomes is about to be published in Europe, in Portugal.
Wonderful. I look forward to reading it.
And with that, we're right at our time. I don't see any additional questions coming in, so that seems about perfectly timed. So thank you all for joining us on this webinar. Please feel free to reach out to us with any additional questions that you might have, and we look forward to seeing you on some of our future webinars.